It is first very important to understand fundamentally what a coax connector is and how it works. A coax connector is functionally an extension of the coax cable and provides a means to connect the cable to an electronic device at the cable termination side. The center contact of the connector connects to the center conductor of the cable and extends it through the connector body. This is the signal carrier. The white dielectric of the cable butts against the connector insulator inside the connector. This is the insulator. The braid folds up over the crimp area of the connector, and the crimp ferrule slides down over the area, and using a hex crimp, the ferrule is crimped around the braid to hold the connector onto the cable. This is the ground. Jem has over 30 years of experience in the design and manufacturing of coax connectors. This vast experience has allowed us to develop solutions for the various problems that pop up from time to time. Today, we have the single broadest product offering of connectors and video balance in the marketplace. This allows us to offer a specific product for a specific application. The result is a cost-effective install operating at peak performance. In today's market, it is critical that you take into consideration several electrical, mechanical, cost, and quality performance factors in order to select the most appropriate coaxial connector for your application. First is to review your system's frequency requirements and cable run lengths. Generally, RG59 cable is used for up to 700 feet, and RG6 is used for longer distances up to 1,000 feet. Most CCTV systems operate below 1 gigahertz, but you should know the VSWR insertion loss characteristics of the different types of connector designs to have the actual facts clearly stated. This chart shows actual electrical testing. Test results represent a 100-foot length of RG59 cable with connectors on each end. The lower the VSWR value, the better the connector. As you can see, our compression seal connector is the best electrical connector within the chart, having a VSWR of 1.350 at 1.71 gigahertz, whereas a typical twist-on connector is not as good, having a 1.716 VSWR at 1.71 gigahertz. We also took the opportunity to test one of our competitors' compression connectors, and you will note that their performance is 1.529, not as good as our compression seal connector. Why is this important? It is simple. Because you want to have a good electrical connector to guarantee electrical purity within your system. You will hear 50 ohm versus 75 ohm. First, this is the impedance of a connector, cable, or system. In the connector world, it relates to the mechanical dimensional ratio of the center contact and the insulator. In the CCTV market, a 50 ohm connector is perfectly compatible with the 75 ohm cable being used. This tiny area of mismatch will not cause any degradation to the signal. Now please refer to the two connectors and the arrows that are pointing to the mating face. Note the insulator, which is the white material on the 50 ohm connector, is all the way out to the front of the connector, while the 75 ohm connector's insulator is nowhere to be found. It is much further back inside the front or mating face of the connector. This is how you can tell a 75 ohm connector from a 50 ohm connector by looking at that white insulator in the front of the connector. If you can see it right up front, it's a 50 ohm connector. If it's way back in the body of the mating face, it's a 75 ohm connector. However, in the audio-video market and broadcast industry, it is highly recommended to use a 75 ohm connector. In fact, if the system is operating at a frequency above 1.2 gigahertz, it is absolutely mandatory. Now that we have reviewed the electrical characteristics of our connectors, it is now time to turn to the mechanical integrity of the connector cable termination. This is a very important characteristic and one that is highly misrepresented due to incorrect assembly procedures used. This parameter is important as it is the single most significant factor that can seriously degrade a system. that is a bad ground, connectors falling off, and or loose, causing intermittencies. Please take a moment to look at the chart. The twist-on connector has a cable retention value of 22.05 pounds, whereas our compression seal connector is 52.91 pounds. Not at all surprising based on the type of termination styles these two connectors use. And you will note that the crimp-on, uni-crimp, and crimp-crimp are in between, and our competitor in the compression seal is not as good as our 52.91 pounds, but is in at 41.89 pounds. This is a very important characteristic for you to review when choosing your connector, because what you want your connector basically to do is to hold on to the cable as hard as it possibly can. All systems are as strong as its weakest link, and a connector can provide that weakest link. So you need to review these results and choose the proper connector you want to put into your system. During this presentation, I've talked about different types of connectors. It is now time for me to describe those different types and how they were designed and what their function are. You can at any time refer to the cable assembly videos that were prepared that will show you exactly how each one of these connectors are put onto cable. It is important for you to understand the basic differences between the various types of connectors and their individual benefits. The following summarizes those distinctions. I will first start with a twist-on connector. This connector was originally designed with a specific thread ID, pitch, and sharpness to guarantee a proper cable affixement process and cable retention. The connector was designed for RG59 cable with an OD of 0.245 inch. However, today cable ODs range from 0.195 to 0.245, which calls into question the long-term viability of the connector. Because the thread is designed for a 0.245 cable, and if the cable is 0.195, the connector will not tighten down properly. However, if the cable has the proper 0.245 inch OD, the twist-on connector can be a very cost-effective solution if terminated to the cable properly and is completely reusable. I will now describe the universal crimp-on connector that was designed by GEM Electronics about 11 years ago. This connector solves the potential cable connector dimensional discrepancy problem in that it is not vulnerable to fluctuating cable ODs. However, it is vulnerable to braid coverage, thickness, and material. These issues occur infrequently, and thus there is little concern with the long-term reliability of this termination. This product is perfect for the service call environment, as it is one connector with 3 ferrules in the bag that will terminate the following cables: RG58 PVC, RG59 PVC and plenum, and RG6 PVC and plenum. Thus you have one connector for every job that you go on and one crimp tool that is available that will crimp all 3 crimp ferrules. I will now turn to the crimp-crimp connector. This connector is generally used for higher frequency applications above 2 gigahertz, as the center contact is more closely dimensionally matched to the center conductor of the cable. This, combined with a crimped and or soldered center contact, provides a lower VSWR even at frequencies up to 4 gigahertz. This connector is also used for a cable with a more flexible stranded center conductor. Here, a 75 ohm connector should be used if system operating frequency is above 1.2 gigahertz. The next connector is the uni-crimp connector. This connector was developed to be a more cost-effective compression seal type connector. The uni-crimp design employs the same internal construction as the compression seal, but in lieu of a special compression crimp tool, a standard hex crimp with a 0.320 hex will work. Most importantly, this internal design provides for the connector hex to crimp down on 2 braids and the outer jacket of the cable. This is accomplished by folding the braid back after stripping the cable properly and inserting the cable dielectric into the inner cone structure of the connector. The internal construction now has the cone, the inner braid, the cable jacket, and the braid that was folded back. This is what the hex crimps down on and provides a very substantial structure to crimp down onto. The assembly procedure for the uni-crimp also has fewer steps than the crimp-on type product and can save time in the termination process. I will now describe the compression seal connector. This is a high-end product. It is designed for use with cables ranging from RG59 plenum, 59 PVC, to RG6 quad and RG6 quad plenum. However, for RG59 cables, it has been specifically designed several times to accept a cable range of 0.195 to 0.245. It has basically the same internal cone design as the uni-crimp, except instead of an external hex crimp, this employs a 360-degree plastic insert completely capturing the cable components to the inside walls of the connector. This plastic compression sleeve is tapered such that it will fill all available space, and then some, to produce a cable retention that is far superior to any other connector design. Once this connector is properly installed, it cannot be pulled off the cable ever. The connector also has an internal O-ring to seal the mating surface from water wicking up the cable. A properly mated pair of F connectors are completely waterproof. They have been tested in a 3-foot head of water. The concept was to develop a line of products that could be used by the installer for the CATV, CCTV, and home theater systems markets, using one assembly procedure and one crimp tool for F connectors, RCAs, and BNC connectors. This connector will cost more than the previously discussed items, but there will never be a service call as a result of a connector pulling off the cable.